A flame test is a procedure used in chemistry to detect the presence of certain elements, primarily metal ions, based on each element's characteristic emission spectrum. The color of flames in general also depends on temperature. See flame color. The test involves introducing a sample of the element or compound to a hot, non-luminous flame and observing the color that results. Samples are usually held on a platinum wire cleaned repeatedly with hydrochloric acid to remove traces of previous analytes. Different flames should be tried to avoid wrong data due to contaminated flames, or occasionally to verify the accuracy of the color. In high school chemistry courses, wooden splints are never used, mostly because solutions can be dried onto them, and they are expensive. Nichrome wire is also sometimes used. When using a splint, one must be careful to wave the splint through the flame rather than holding it in the flame for extended periods to avoid setting the splint itself on fire. The use of cotton swab or melamine foam as a support have also been suggested. Sodium is a common component or contaminant in many compounds, and its spectrum tends to dominate over others. The test flame is often viewed through cobalt blue glass to filter out the yellow of sodium and allow for easier viewing of other metal ions. The flame test is fast and easy to perform and does not require any equipment not usually found in a chemistry laboratory. However, the range of detected elements is small, and the test relies on the subjective experience of the experimenter rather than any objective measurements. The test has difficulty detecting small concentrations of some elements, while too strong a result may be produced for certain others, which tends to drown out weaker signals. Although the flame test only gives qualitative information, not quantitative data about the actual proportion of elements in the sample, quantitative data can be obtained by the related techniques of flame photometry or flame emission spectroscopy. Flame atomic absorption spectroscopy instruments made by, for example, Perkin-Elmer or Shimadzu can be operated in emission mode according to the instrument manuals. Common elements. Some common elements and their corresponding colors are: arsenic turns blue, boron bright green, barium turns pale or apple green, calcium turns brick red, cesium turns blue violet, copper 1 turns blue, a copper 2 non-halide turns green, a copper 2 halide turns blue-green, iron turns gold, indium turns blue, potassium turns violet, lithium turns red, manganese 2 turns yellowish green, magnesium turns bright white, molybdenum turns yellowish green, sodium turns intense yellow, phosphorus turns pale bluish green, lead turns blue or white, rubidium turns red-violet, antimony turns pale green, selenium turns azure blue, strontium turns red, tellurium turns pale green, thallium turns pure green, and zinc turns bluish green.